we've got our microservices created according to the 12-factor approach. We integrate those services in 3 different ways using server-side include, edge-side include, and client-side include. We deploy everything onto Heroku. Now the question is, what happens in between? How do we actually move the software from version control to production? So let's talk about the orchestration of our deployments. And the first way we can do that is to do everything manually. And I know it may be shocking for many people because we've been trying to introduce continuous integration to the enterprises for so many years. And now I'm telling you, deploy everything manually. Well, under some circumstances, it makes sense. So let's say that you've decided that you're going to run some experiments and you're going to create a new microservice. And this microservice hasn't proven itself yet. So you want to first run it in production for some time, see if it makes money. During this initial period, there's only going to be like one developer or only one pair of developers working on that microservice. And there's no reason to continuously integrate with other people because there's only one person working on this thing. So in those circumstances, it makes sense to do everything manually. So what does the workflow look like in this situation? Well, you basically get the code from your version control system, and we use Bitbucket for that. And then you run all the builds and tests on your development machine. And when you think, it's ready, you just push it to Heroku. And Heroku popularized this git push deployment mechanism. And after this git push, Heroku builds your binaries, and then you can promote the same binaries to other environments. It's actually very, very important that you build your binaries only once, and then you promote the same binary to the other environments. And we use the Heroku pipeline promote command for that. But at some point, you may say, this microservice has proven its usefulness. We're going to involve more people into this stream of work. And at some point, running those 3 commands on your local machine becomes kind of boring. And now you say, let's use some continuous integration as a service tool, some tool in the cloud so that we can outsource continuous integration to someone else, and we don't need to maintain our own infrastructure. And we tried 3 tools, Travis CI, CodeShip, and Snap CI. And I want to tell you about some of the killer features of those 3 tools. So one thing I really, really like about Travis CI is this YAML file that allows you to version control the actual settings of your continuous integration setup. And it's a very, very powerful mechanism. Unfortunately, Travis doesn't support Bitbucket that we use, but we still use Travis for some of the open source projects that we host on GitHub, and it's really, really good at this. The second tool we tried is called Snap CI, and the killer feature of Snap CI is the really nice visualization of the deployment pipelines. But unfortunately, again, Snap CI doesn't support Bitbucket as of today. I know they have it on their to-do list, so we'll probably get back to evaluating Snap CI sometime in the future. And the third tool we've tried is called CodeShip. And the killer feature of CodeShip are those Docker containers that they use as their build agents. And you can actually log onto those containers and see, for example, why your build is failing. Really, really nice feature. Unfortunately, CodeShip doesn't have this file with the CI configuration as Travis has. So when you have like 20 or 30 services, it's really, really difficult to manage CI configuration. So that's why we decided not to use CodeShip. So, if none of the cloud CI tools works for you, you may say, let's use a self-hosted CI tool. And there are some obvious candidates like TeamCity, Bamboo, and Jenkins. But we didn't use any of them, and let me explain why. Well, to set some context, I want to actually refer to this book by Eric Evans, Domain-Driven Design. And in chapter 8, he talks about this thing called a breakthrough. So what is a breakthrough in a domain modeling process? Well, let's ask Eric Evans himself. Here's what Eric says. an opportunity opens up to transform your software into something more expressive and versatile than you expected. This can mean new features, or it can just mean the replacement of a big chunk of rigid code with a simple, flexible expression of a deeper model. And while this does not happen every day, it's so valuable when it does come up that the opportunity needs to be recognized and grasped. So what does it mean in practice? So let's say that 10 years ago, you decided to build a CI tool, okay? And you modeled the core domain of your CI tool around the concepts of continuous delivery. So probably you're gonna have things like jobs and tasks and builds in your domain, in your code base. And you become very successful, people start using your tool, and several years later, people start talking about continuous delivery. People start talking about extending the concepts of continuous integration up to the production environments. And if you listen to people talking about continuous delivery, they use different words, right? Because it's a much richer domain. So people start talking about things like value streams, like pipelines, like stages. And those things are missing in your core domain. And what can you do? Well, you can either pretend that, oh no, our old domain model is still good, and you can keep hacking around the limitations of your old model by building some UI widgets that visualize pipeline on the top of the old model. Or you can actually use a tool like, for example, GoCD that's explicitly built around the concepts of continuous delivery. Now, if you start using any tool like either GoCD or even Jenkins, well, the first thing you're gonna do is probably you're gonna click through the user interface to set up your pipelines. And it's okay to learn how the tool works, but over time it becomes boring. And you can't actually track what you've been clicking over time. So the first thing people normally do is they look for some configuration file, some, for example, XML file that has a configuration of all the pipelines, and they keep it in their version control. But here's the thing. Over time, this file becomes huge, and it's like really difficult to like diff different versions of this file and track how it changes. But fortunately, some folks at Springer came up with this tool called GoMathing, which actually allows you to describe your pipeline as a code. It's actually similar to Jenkins job DSL. And it's a really, really nice concept because now you can describe your pipeline as a code, as a Python code, where you can actually extract parts of the code base into like little functions, reuse it. It's just a regular programming language. And now you can express your pipelines in a programmatic way.